All right, so now we're going to move on to some area and areas of some similar figures. So here's a little scenario. So see that beautiful mosaic diagram on the left side? Oh, beautiful. So let's say an artist used 200 tiles to make that design and say the dimensions were 2 by 3. Somebody said, I love that. I want that on the side of my house, 10 feet by 15 feet. So notice, the length is multiplied by 5. 2 times 5 is 10. 3 times 5 is 15. So the artist said, okay, I used 200 tiles. 200 times 5 is 1,000. Oops, I ran out of tiles. That artist didn't know geometry. Let's see if we can help that artist a little bit. Let's think about some of these things. So I've got some rectangles here, and I want to do some areas and compare some areas. So first of all, this one, 2 times 5, the area is 10. 4 times 10, the area is 40. So what's interesting here is that the ratio of the sides, in this case, the sides have a ratio of 2. It's like a 2-to-1 ratio for the sides. But the area is a 4-to-1 ratio, because 40 is 4 times as big as 10. So even though the sides have a dilation of 2, the areas have a dilation of 4. Let's keep playing. Here's 2 more triangles. 2 times 4, the area is 8. 6 times 12, the area is 72. But now I look at this and I go, okay, the ratio of the area, or the ratio of the sides, 2 to 6. The side ratio, or the side scale factor, we should say, the side scale factor is 3. But now 72 divided by 8, 72 is 9 times bigger. So the area scale factor, or the area scale factor is not 3, it's 9. So now we're thinking, what's the pattern? If I went from 2 to 4, if I go from 3 to 9, maybe you start seeing a relationship here. Here's our conjecture. If corresponding side lengths or the radii of 2 circles are in the ratio of m to n, their areas are m squared to n squared. Or if you want, we can write that as m to n squared. It's a squaring ratio. And that should make sense to you, because if you multiply the length and the width by some number, you've just increased the area by that same amount. If you think about it, let's suppose we call the dimensions like x and y. So the area of this is xy. If I multiply it by, say, 2, and I get 2x and 2y, now my area is 2x times 2y, or 4xy. So doubling the size quadruples the area, 2 squared. So interesting stuff there. Let's play with some problems like it. So the first one says, if the sides of 2 similar triangles are in the ratio of 3 to 5, what's the ratio of their areas? Well, we know that if the sides are 3 to 5, to get the areas, square it, which is like doing 3 squared over 5 squared. So the ratio of the areas then is 9 to 25. And if we go the other way, if the area ratio is 36 to 49, then what we want to do is we want to take the square root of that. So it's the square root of 36/49, which is just the square root of 36 over the square root of 49, which is 6 to 7. So some good things there. Let's solve some equations with it now. Let's say that the ratio of the sides of 2 similar triangles is 3 to 4. And the smaller triangle has an area of 18. So what I know is, that's my side ratios. If I square it, if I get 3 squared over 4 squared, or 9 to 16, that's equal to the ratio of the areas. So the smaller one is 18, the larger one is x. If I solve this equation, I can either cross multiply, means extremes property, or I can just look at it and say, well, 9 times 2 is 18, so 16 times 2, x is 32. And I can go the other way as well. if I know that the ratio of the areas is 4 to 49, again, that's an area ratio, 4 to 49. So I know that ratio, if I take the square root of it, I get the side ratio, which is 2 to 7. And if one side of the larger triangle is 7, that's the larger one, so the smaller one's going to be on top. So the smaller side length would have a length of 2. So I know you're saying, where do people use this? Well, if you are a pizza maker and you're trying to figure out how much cheese to put on top of your 16-inch diameter pizza, and you know that 3 ounces cover a medium 12-inch diameter pizza, how much cheese would you need? Let's think about it. So I know that that my diameter is 12 for the smaller one. So let's figure out how big the area would be. My radius is 6 for the smaller one, so the area would be 6 squared, 36 pi. And when my ratio is, or when my radius is 8, my area is 64 pi. So the ratio of my areas is 36 pi to 64 pi. Now that reduces, cancel them out, 36 to 64. So that's my area ratio, which means if I take my square root of that, the side ratio is going to be a 6 to 8 ratio, the square root of it. And I know that 3 ounces of pizza, 3 ounces covers the smaller one. How big is the larger one? So if I cross multiply here, I get x equals 4. So you need 4 ounces of cheese to cover the large pizza. I just solved the problem of all those pizza makers.